Alright, in this video, I'm going to answer the question, what is a tangent? And what you're going to see is the answer to this question is really sort of a fundamental one to calculus. And now when I ask this question, usually at the beginning of a calculus course, most students have seen the concept of a tangent before, if you've taken physics or science or something like that, and they have a pretty good idea of what a tangent would look like, but the trick is to define it accurately. So one thing that I usually hear when I ask this question is it's a line that intersects a point once. So a line that intersects a curve once. And that's an okay definition if you're dealing with a certain type of curve. So if you're dealing with a circle and you want a tangent at a point, let's call this point P, then yes, the line which touches that point P on the circle exactly once is in fact the tangent. So this is a good definition for a circle. But if you're dealing with a more complicated curve, this definition doesn't quite work, and we need to kind of refine our definition. So to see what I'm talking about here, take a simple curve. So just take something like as simple as a parabola. And if I were to draw a point P on this parabola, so right here, so here's my point P. Now if I were just ask most students who've seen this definition or this concept of a tangent before, they could draw the tangent. They'd say, okay, well, it touches the curve once, so it's just going to go through the curve right at that point there. And that line does, in fact, touch the curve once, and it looks like a pretty good drawing of a tangent. However, I could draw you another line which intersects this point, this curve once, which is clearly not the tangent. Right? So this one right here. That line there goes through the curve once at point P, just like the other line, but it's not the tangent. So we need to refine our definition of a tangent. So what some people will say is, okay, well, it doesn't cross the curve, it just kind of touches it, but doesn't go through it, which is not bad. It's a decent definition, but it's not really precise mathematically. So we'll try to come up with more mathematical definition, and actually that in coming up with a mathematical definition, that's actually where sort of the calculus comes in and why we have this this idea of why calculus sort of became what it was. Now the idea of a tangent only touching a curve once, that's actually not necessarily true, because a tangent could touch a curve more than once. So consider a curve like a cubic. So there we have a cubic. So let's say I put the point P here. Then the tangent would be kind of right there, just touching it once. But if you extend that line, would actually hit it again over here. So a tangent might actually hit a curve more than once, depending on the nature of the curve. Now, you'd have to refine the definition, and sometimes what we'll say is it touches the curve just once around that point of intersection, which is true. That's a good definition, that it'll just hit it once. A really good definition of a tangent, or a more precise or a better idea of what a tangent is if you think of the curve. Now if I were to draw any curve and a point P. Now this is actually a curved line. It's not a line, but it's a curve. But if you were to zoom in on this point, right? If I were to hit zoom on the computer, and I could do that, I could zoom in, right? And if I were to zoom in again, and again, and again, and again, I can't zoom in anymore on this program, but the more you zoom in, what's this curve eventually going to start to look like? Eventually, any curve is going to start to look like a straight line if you get close enough to that point. So that line that the curve sort of approximates when you get really, really close, that's the tangent. So a nice way to think of a tangent is sort of as a linear approximation to the curve right at that point. But we'll get into more mathematical definition of how you actually figure that out. But that's what a tangent is.